Hey everyone, we're going to be working on the SparkFuns, but before we really get into any SparkFunning, gotta hit myself up with this lint roller one more time. I know we're live, but we're gonna lint roller still, cause gosh darn it, can't have stray lint when I'm doing electronics. I don't think that's actually an electronics thing, is it? Okay, so with us today is our good friend and pal, Zenhavr. He's going to be helping us understand what we're trying to do today.
Hello, everyone. I will be doing my best to do that thing. No
Sure.
guarantees that it will actually happen.
I've been simply devouring YouTube lately on electronics, and I think still I understand the things that I've learned through your esteemed guidance more from that than through YouTube, through many YouTube videos. So I appreciate it.
Very happy to hear it.
Yeah.
As a enjoyable aside, I am currently drinking a cup that is almost identical to yours, with one small exception,
Oh,
that it has a different letter on it than a G.
I think there's another subtle difference, is that yours does not have 3-day-old coffee in it.
that is a minor
We're gonna
difference.
we're just gonna push this out of frame here. Push that aside. It is disgusting. Um, I don't have any beverages. This could count as a beverage. I was using this as a drawing tool earlier. If you shake it, there's clearly liquid inside, but I think that might be a bit cloying to use as a relaxing drink.
Yes, we'll keep that one on the back burner.
In the long dark, though, eating canned peaches does reduce your thirst. So there's that.
QED, canned sliced peaches are a drink.
Yep. So yeah, I'm starting a bit late tonight. I just got done with a nice windy drive. Yeah, 3-day-old coffee. Just got done with a nice windy drive, and I am just psyched to continue working on this. I have, um, it's been nigh an obsession the past couple of weeks, and it just continues to grow to learn more about these lovely devices. And I've had to stop myself from just barraging Mr. Zenhavr here with constant questions that just go further and further down a rabbit hole every time. Um, so one of the things that I've been learning about is that, and I'm interested to learn more, is that these things here, these little bits, the black bits that have all the little silvery bits on them, are most of what we're dealing with. All the rest of it is just kind of extra. I think you were starting to explain some of this to me, Mr. Zenhavr, and I would love to learn more about how these Arduino boards are actually just like microchips, and the boards are just to make it easier. Did I understand that right?
Yes, that is essentially correct. So, if
That's
you were
wild.
to zoom in very closely on the square IC integrated circuit,
Let's see how close we
um,
can get. I don't know how our camera work is today. Oh, we can get pretty close.
so it's on the kind of the lower left quadrant, the one with many pins coming off of it.
This one here, I think.
Yes, that one. So that is the heart and brains of an Arduino. That is an Atmel AT some flavor of uh, AT like 328.
Okay.
Each one of those little silvery bits are referred to as pins,
Right.
and basically each one of those pins is broken out to one of the black. Each pin corresponds to like a black socket on the left and right sides. So those
Each of
um,
these
Yeah.
connects to one of these fun boys.
Yep. And
Cool.
so basically, an Arduino is a nice package in circuit board form to give you easy access to all of the pins on one of these microcontrollers. So that's what Arduino, the company, does. They
Okay.
make open source circuit board designs that all have some measure of like, what's the way to put it? Focusing on ease of use.
Okay.
So,
How,
like, yeah, go ahead.
how does that correspond with like the Arduino IDE and the programmability of it? So like
Hmm.
is this chip specific to the type of language that we are inputting, or does something else happen in between through the Arduino IDE to prepare it to be used by this particular microchip?
That's an excellent question. We are getting down into some of the real nitty gritty details
Yes.
of embedded system
I
design.
love nitty-gritty details.
So there's asterisks and nuances kind of all over the place as we're talking about this.
Scattered
But the
about.
the Arduino IDE is a nice interface to type code into in order
Mhm.
to deliver it to the compiler.
Okay.
The compiler, I believe, is provided by Atmel, the maker of the microchip, the microcontroller.
Okay.
Basically, every microcontroller has a different set of like hardware instructions that are specific to that microcontroller. They are determined by the integrated circuit design itself. Every line of code that you type in the IDE corresponds to some large number of instructions to actually make
Okay.
that thing happen in the microcontroller. And so, in order to translate code to a specific microcontroller, that microcontroller's manufacturer typically provides like a compiler
Okay.
to do that translation. And
So
so,
that is pretty specific then.
Arduino, it is pretty specific. The Arduino IDE is, a nice fancy faceplate to uh, basically enter the inputs to that compiler.
And just for to explain the acronym, IDE stands for Integrated Development Environment, and they typically are just something that is, um, and you might have a better definition of this than I do, but usually I go by it color codes and does potentially some auto correcting and some hinting to make it easier to do software development than any coding.
That is absolutely correct.
Cool.
You could open up notepad.exe and type a bunch of code, and the compiler would likely be able to take that and do
Sure.
its thing. The IDE is just a nice, easy to use interface to that.
There's um for the classes that I teach, we used to have a Dreamweaver class, and I've replaced that just with Sublime Text. And
Mm,
Dreamweaver is an IDE kind of paired with a preview for website design, and we've just replaced it just with the IDE through Sublime Text because it's so much more lightweight and so much more expandable than Dreamweaver, and also doesn't cost you a ton of money every single month for a somewhat useless program. But um,
huh,
IDEs are super cool, and there's like a zillion of them. There's a whole bunch of them, and they all have different engineers and developers have different tastes in which ones they prefer, at least in the web world. For work that you do professionally, is it a standardized IDE that's used for certain things? And if you can't answer questions, feel free to just um, deflect, of course.
understood. We have all we have as a group, a software group. Our couple dozen large software group
Yeah,
has converged on one specific IDE, and that helps a lot just with being able to like share certain user configurations
sure.
around, share like certain scripts around. It helps out a lot for making sure that everyone is on the same page about certain features and interfaces and stuff.
But at one point, that was not the case.
It has certainly always been the case since I've worked there.
Sure.
I suspect that it was not always the case.
Based on horror stories.
Yes.
Gotcha. Thank you for explaining about the microcontroller or the microcontroller there. This does lead me to another question, and I'm going to bring back something that I showed on the very first day of doing this, and that is my electronics learning lab from Radio Shack. And so I was just looking at this the other day, picked it up for nice and cheap a while ago. This is a really cool thing. I really couldn't get myself into the instructions were just quite dense, you know, like especially compared to the stuff we're working on right now. I was bothered by the Comic Sans, and I also found it just a little bit cumbersome to understand what I was supposed to do. But this page right here talks about some of these microcontrollers that it has, and I know I could probably, you know, read this and it would tell me, but I noticed that they have like a bin of stuff, which is in here, I think. They have a little bin. They did have some MOSFETs in here, which I thought were super cool. Because I've looked at some projects that could maybe use those, but they have some of these integrated circuits. Like they have like the 555 one, I think I've used. And so how are these just microcontrollers that have already been programmed with a certain set of instructions, or are these kinds of integrated circuits common to be used still in the kind of work that we're doing with the Arduino?
Those are all excellent questions. Let us dive in and
Sorry.
start talking about some of that. So let's talk a little bit about terminology.
Okay.
So integrated circuit refers to basically any chip like that.
Okay.
Um, any little chip that's got pins coming off it like that. That's what we would call an integrated circuit.
Yeah. So a
A,
microcontroller is an example of an integrated circuit.
a microcontroller is an example of an integrated circuit.
Cool.
When I use the term microcontroller, I am referring to an integrated circuit that is able to execute software, has inputs and outputs, has flash that stores code, and it has RAM that's able to store variables. It has a clock input that it tells you how fast it runs at. It's basically an entire computer on an integrated circuit. So that's what I mean when I say microcontroller.
Okay. Gotcha. Thank you.
These specific integrated circuits that we're looking at right now
Hmm.
are almost certainly just special configurations of transistors, which means that they are hard baked into the silicon.
Okay. So
These
like
would
if
never be able to do anything other than what they were specifically designed to do.
Gotcha. And but there are enough of those like common tasks that these kinds of integrated circuits, and it's hard to see, but there's some tiny Texas Instruments logos on here.
Yes.
Um, so those kinds of tasks are common enough where this is still, and I know it's such a generalization because we're just surrounded by electronics all of the time.
Hmm.
But on like on any projects that you've worked on, have you ever used any of these integrated circuits that are kind of hard baked?
Yes, those are pretty common, especially things like the 555 timer, things like AND gates, OR gates, NAND gates. All of those kinds of really base level integrated circuits are pretty common to
Sure.
use in projects. Um, so a lot of these sort of special integrated circuits are like pretty standardized. Like you could take the model number for that Texas Instrument chip and find one from, Atmel or other IC makers, and they would be interchangeable.
Oh,
They're
really?
pretty standardized. Um, I'm just going to send you a quick link to a Wikipedia article to kind of illustrate how standardized some of
Sure.
these chips are
Let me pull it up.
for future reading.
Um, so that begs the question then, like, um, why would you choose to use a hard-baked integrated circuit when you could use a microcontroller to accomplish a microcontroller and software to do the same type of task?
That is, you are nailing it with the questions tonight. These are
Yes.
all very logical questions to ask.
Good.
There are a lot of really good reasons to use a specific integrated circuit, like of the 7400 series.
Yeah.
You absolutely could use a microcontroller to do any of these things, right?
Sure.
The difference is that like a standard microcontroller costs probably $3 or $4 for that chip.
Sure.
Any one of these integrated circuits are going to be like pennies.
Oh, okay.
These consume orders of magnitude less power to do what they need to do. They are also insanely fast. Like these are, since what they do is hard baked into the silicon,
Yeah.
they basically will turn on and off or like execute the logic that they have associated with them as fast as the electricity can flow through them. Whereas a microcontroller is clocked. Like
Sure. Yeah.
you have an oscillator that's sending, like a 1 meg clock or something into a microcontroller. And so it can only ever do things on each one of those clock cycles. So they are
Right.
way, way slower comparatively than these integrated circuits.
That makes sense. So you can, that's maybe why you want to call, or why some people call these microcontrollers more like prototyping boards, right? Like,
Yes.
are, is it, a common thing to take some piece of software developed for a microcontroller and eventually turn it into one that uses more hard-baked integrated circuits, or like where the prototyping and stuff is done more on the software level and then it's eventually sped up by using those devices, or does that not happen as often?
That is uncommon, but
Okay.
certainly not unheard of.
Sure.
What that process usually entails is certain integrated circuit makers will provide sort of like a prototype board that lets you like program it and load code onto it and sort of for all intents and purposes act as like a microcontroller or like an Arduino. But then you can sort of work with them and hire them to take the code that you've written for the prototyping board and turn it into what's called an ASIC,
ASIC.
ASIC, which
Okay.
stands for Application Specific Integrated Circuit.
Okay.
It essentially You essentially contract with that chip designer to create an integrated circuit that does in IC form what you have like programmed their prototyping board to do.
Cool. And that's probably expensive, I'm guessing.
Yes, extremely
Extremely
expensive.
expensive.
You
That.
would typically only do this if you needed, hundreds of thousands
Sure.
of a chip that did this very specific thing.
Where the dollar that you save by doing it that way would make up for in quantity on
Yes.
the initial price. I don't know if
Yeah.
that sentence actually made a lot of sense, but you got it.
Made sense to me.
Cool. Okay, I think that was some of my questions that I had. I love all of the stuff that kind of explains some of the why this stuff is the way it is, why it's configured the way it is. That really helps me understand like what I could do inside of that, I guess. I don't know. It's fascinating to me, especially just like how gosh darn surrounded by this stuff we are. It's like in every single thing. There's so many like I have like 2 dozen devices within arm's reach that are just lousy with circuitry. So it's really fun to learn about it, how some of this stuff works. So
Yeah,
thank you.
microcontrollers are insanely prevalent these days. You've got a microcontroller in your microwave, your
Mhm.
fridge, your washer, your dryer, everything that has like a digital display to it that does any sort of complex control
Mhm.
of mechanical stuff, it's going to have a microcontroller that's taking care of that.
So neat. Um, what is your go-to um, hard-baked integrated circuit? What's your favorite one to use?
Oh man, they are so they're so specific in what they do. I particularly am partial to the 555 timer
Mm-hmm.
IC because it can be used for a lot of different um, interesting things. It can generate clock signals. It can make all sorts of different waveforms like square waves, sawtooth waves. It all depends on sort of what you have hooked up to it externally. It's very
Okay.
versatile.
I know nothing about waveforms. I think that might be a little too much for me today.
Yeah, that's very electrical engineering specific. So
I think I have a friend whose dad has an oscilloscope. Is that the right way to say
an
that?
oscilloscope, yep.
Yeah,
Hmm.
and they use it to fix a sensor or like figure out what was wrong with a sensor in his Honda Insight. They were like able to do some like really absurd debugging in their car because they had an oscilloscope, and it just seems like magic to me. It's
Yeah,
really
I love that.
so darn cool. Um, awesome. Um, I have from your recommendation. I showed a. Maybe I'll even show it because it is. I've described it before as soldering gore. I'm going to pull up that picture of the soldering gore because it is particularly bad. I was doing a soldering project for my friend Zet Wilder not too long ago. Where I fixed a pair of headphones of his, and I soldered it to fix it. It works somehow. Um, I'm very pleased that it works, but the soldering job that I did is less than sanguine, maybe we'll say. Find that picture, and here we go. So this is the soldering job that I did for his headphones. And Zenhavr, you recommended that I pick up, after that, pick up some of this solder wick stuff for this kind of scenario. So I got some of that here. I'm excited about it. Some solder wick. And so I'm going to be adding this to my kit of different electronics toys so that the next time I solder, it's not so terrible. So thank you for that recommendation. I do have some flux that I've purchased in the past, but it's in like a pretty big pot. It's like in a thing that is kind of hard to get into, and it'd be hard to bring with everywhere. And I kind of don't want to have all my electronic stuff in one spot because I have a toolkit that I bring with me. Um, oh, nice! It's not too noticeable when it crackles. That's good. Yeah, I'm surprised, but I've been thinking about it, and if we have to, we could just bypass the whole volume control if it gets bad again. Um, so I'm thinking about what to split up my some flux. I have the flux container, but I'm gonna have to split it up into smaller containers so I can have a few different around. Um, have you ever used the flux pens before?
I have personally not. No.
Because it looks like there's some like marker type things. Do you typically use like a flux pot with a brush when you're soldering?
I typically do not apply flux on
Oh,
on my own.
okay.
Usually I'm able to just solder things directly.
Because you're better at it
uh,
than okay.
I mean, I think the solder itself actually has flux in it.
Oh, right. Like the flux core lead-free
Yes.
solder is usually
Yes.
what. Um, I also picked up a new soldering iron, and this was like it was like $12. Picked it up. I still haven't opened it yet, but it's a It is a USB soldering iron, and it's just a little guy that was an 8 watt, but it was from a YouTube channel that you recommended. What's that guy's name again? That you recommended?
I do not remember.
He's got a beard and is, I think, Scottish, if that helps.
Yeah, I know exactly who you're talking about, but the name is completely escaping me.
I'll post a couple of his videos to start posting some of his stuff to Twitter because it's been really helpful. He recommended this thing. He got it for $5 on eBay, and I'm too impatient and not trusting of eBay to do a whole lot from there. I'll have to ask. Have someone who does a lot of eBaying that I know. I'll have to ask them for some advice on that. But this little thing, so I actually got 2 of these. One is for my main toolbox that I bring everywhere, and then this one will be for my at-home kit. But I'm quite excited about it. He said it works just fine and nice and cheap. So I had a butane one in my regular toolbox, and on the project for Zet Wilder, I used up all of my fuel and I just filled it in, I think, like 7 minutes of soldering. And that's no good, because if I had any actual vehicle emergencies that required soldering, I'd probably need it for more than 7 minutes. So I'm excited to have that in my kit and to eventually move these SparkFun projects along to that. So I know we're like not actually talking about the SparkFun projects yet, but I had all of those questions and wanted to show you that I got some of that solder wicking. So I think I'm gonna get to it though. So when we left off last week, this is where we were, and I was doing a thing. What was I doing? I think we just plug it in and see what it does, right? That'll tell us what it does. I think it was the Simon Says game with the trumpet sound. Yeah. I think this controls volume. Let me reset. That's not very loud, but yeah, so they have this game here, which actually has a pretty neat chunk of code to make it work. So I'm going to pull that up as well. Arduino IDE. So I think we are ready to go on to project number 3. And this is something that Inorganic Mechanic was asking about, is and excited about using servos and things. So here's the, looks like this is 2A. Let's open up the other one. 2C, this is the Simon Says game. So this is all of what went into this game. I still need to dive in a little bit further to it, but we were learning about arrays and utilizing arrays to store different values. So that's what we're seeing here. And then we're calling in different parts of the array with these numbers in these square brackets, correct? I think that's what that does.
That is correct. Typically, you'd refer to that number inside of the square brackets as the index.
The index, okay, thank you. Which is a good reminder that any of this kind of software work that we're doing is going to be all the numbers are 0 indexed, and that's not just with the software, that's with the hardware as well. Could you refresh my memory about 0 indexing? I know that's a broad topic, but
Sure. So as a lot of beginners into electronics and software will sort of naturally think 1 corresponds to the first item in the list.
Mhm.
Computers, let's see how to phrase it. Computers, their the initial state of any value inside of a computer is typically 0 or off.
Okay.
Computers are at their hearts a whole bunch of transistors that are all either off or on,
Mhm.
voltage applied or not applied, 0 or 1. When you take zeros and ones and start adding them together to make bigger numbers, an integer is like 16 bits, 16 binary states, all of which can be either 0 or 1. The very first and initial state of that integer is all zeros.
Yep.
And from a computer's perspective, the first state, the initial state of a value, which is all zeros, should correspond to the first item in a list,
Yep.
if that makes sense.
It does, and we see that too. We see it with hex code with colors. We also see that with on the hardware here. It starts with 0. This is actually the first pin, not the nothing pin. Is I guess a good way to say that. So it's not the nothing pin. That's pin 1. That's the first one in the. It's pin 0, but it's the first pin in there, and so that applies not only to the hardware, but anywhere we're going to be doing the software stuff as well. So, and hex color black is all zeros. So I remember when we first talked about zero indexing a couple of years ago, it took me literally like weeks to really wrap my head around it. So is there any, I guess I should ask, like, is it a concept that usually takes a while, or what are some good ways to remind yourself about zero indexing? I guess it's not, once you get it, you just get it. It doesn't seem like that hard of a concept, but
hmm Yeah, it gets a little bit into, you have to understand kind of how numbers work inside of a computer.
okay.
A number, if we think of sort of the most basic number in a computer, which is a 1 byte, a number that's stored inside of 1 byte of memory, that's
Mm-hmm.
8 bits. An 8-bit number can take on values from between 0 and 255. So
Okay.
that's the entire range of values that an 8-bit number can take. And if you want to use an 8-bit number as an index into an array, you sort of think about, well, the entire range of values is from 0 to 255. And so it kind of makes sense that the smallest value that that number could take should correspond to the first item in the list.
Mm-hmm.
And then you just kind of go forward from there. Essentially, all number formats rely on their like sort of starting position being all zeros corresponding to a 0.
How does that work with like negative? Are there can there ever be negative values?
Yes, it well not in arrays, but
Okay.
numbers obviously can be negative.
Mm-hmm.
It all depends on sort of the format that you've assigned to the number. If you scroll up to look at some of the other values, like in this program, I suspect that some of them will be defined as like integers. Yeah, int.
Mm-hmm.
Int is a specific number format that tells the computer like how to interpret the raw bits stored in memory that correspond to that variable.
Okay.
There are tons of different data types. There are unsigned integers. You have like floating point numbers.
And floating point numbers are numbers that have decimals, right?
That is correct. Yes.
Okay.
So one of the aspects of an int is that the very last bit in an int data type corresponds to the sign of that value, whether it's
Sign, and that
positive or negative.
does that go into like waveforms then?
No, no, I should say sign sign.
Okay. Sure.
Sign is what you would, yeah. Sign is either positive or negative.
Okay.
The negative sign, positive sign. That's what I mean when I say sign.
Okay. Thank you. So that I got distracted by the phrasing, um, by trying to spell out sign in my head. Um, so can you explain that a little bit more? Like, so the last digit in an integer is the sign.
It is probably not something important to anything that we are doing today. It
Fair.
is
Yeah.
interesting and useful to know if you are really, um, really working closely with like the underlying memory
Sure.
in a program like this.
Sure.
From like the level we're looking at this from, all you need to know is that an int can take on values between like negative 32,000 to positive 32,000,
Okay.
and it's whole numbers only, and that's about all you need to know.
Cool. Um,
I would certainly, I can certainly get into more detail on how numbers are represented in memory if it would be useful, but it is probably too detailed
or
for something like this.
Yeah, I think you're probably correct. I feel a little bit like a kid just asking why repeatedly on some of these things. Like, man, we could be here for a while, maybe for a long time. So that's it's also fascinating. Thank you for explaining that though. Um, and so for indexing though, you can never have a negative index because that doesn't make sense, right? Or a zero, an index of nothing, right?
um, yeah, think of like the index as it's almost like a distance measurement, right? You're telling the computer how far from the start of the array you want to get a value from,
Okay.
right? Like a negative, you can't ever have a negative value for like a distance. Like if I told you to go negative 1 miles from where you are at right now, that would make no sense.
Right. Yep.
So indexing is sort of telling the computer how far forward to look in memory from the start of the array to find the value that you want.
Okay.
So if we think of like the button array, right? There's four values.
Yeah.
And if we think of the array starting at an address of 0 in memory,
Mm-hmm.
if you were to supply an index 0, you're telling the computer, I want you to look 0 places forward from address 0. So it would basically be, okay, you want the first element in the array,
Sure.
a 2. If you put in an index of 1, you're telling the computer, I want you to look 1 places further from the start of the array.
And what happens if you have an array with four places and you look at the fifth index?
That would be typically referred to as an exception, like an out of bounds memory exception.
Okay.
Uh, let's see. It's a bad thing. You should never do that because you're basically asking the computer to look at memory that could be anything.
Yeah.
A lot of like oh, what am I trying to say? A lot of like hacks, like hackermen, they will use um, problems in a computer's array bounds checking to basically like look at memory that they're not supposed to be able to look at. If
Sure.
a computer wasn't properly checking array bounds and you said, I know that this array is 100 elements long, and I also know that the user's password is 105 elements past the start of the array, I'm going to ask the
Sure.
computer to tell me 105 places past the array, and it will give me whatever is in memory at that location.
Oh, interesting.
So that's one of the ways that people will get access to parts of memory that they're not supposed to be able to,
Because
is
it's
through problems in a computer's array bounds checking.
it's not that there's no data in that part of the memory. It's that it's just the array is over, so whatever's left, whatever's in the out of bounds space could still be recalled.
Yes, like if you created
Hmm.
two arrays
Yeah.
sequentially, or in this case, like three arrays sequentially, those three arrays will likely be located in memory one right after the other. So I would actually suspect that if you asked for the fifth element of the button array, you would actually get the first element of the LED array.
Oh, interesting. If the IDE didn't say like no, that's not gonna work,
Correct.
which it probably will check for that.
Correct.
Interesting.
I would suspect that it would scream at you that you're being an idiot if you tried to do that.
You idiot! Gosh, it's fascinating. Um, we're not going to get very far in any of the actual projects today because I really have just been stopping myself from barraging you with questions all week. Um, so thanks for for
You're
answering some of
welcome.
these.
I'm always happy to talk about this stuff. You know, I've spent probably the past 14 years working in some way or another with exactly what we're talking about. So
Neat. That's so cool.
It's very near and dear to my heart.
Um, I should try. I'm just looking at this Project 3, what this has in store for us, and we should at least get it started because I'm so excited about it. So this has two things that I'm thinking about using. So it has the servo motor as a component. It also uses the ultrasonic distance sensor, which I've been kind of dreaming about. The ultrasonic distance sensor, depending on how it behaves with leaves, it could be an interesting way to control the height of a lamp. If there is a way to control the height of, I'm thinking about my little greenhouse project. Um, maybe using an ultrasonic sensor, some other kind of distance sensor to measure how far away the leaves are over time, and maybe check once a day and adjust the height of the grow lights based on that. Could be kind of an interesting application. I don't know how well the sensor is going to work for that, but I'm kind of thinking about along those lines a little bit. But we're also going to learn about some new concepts: the PWM duty cycle, so the pulse width modulation duty cycle, Arduino libraries, objects and methods, digital sensors, data sheets, servo mechanisms. And we're going to be learning how to control a servo motor, how to use an ultrasonic distance sensor, awesome, and how to move objects using servo mechanisms. I've probably watched a good hour of YouTube videos of people using linear actuators and pneumatic linear actuators with Arduinos this week, and it's been really fun. And it's made me think about like making factory things and like mass producing fun things. I don't know really what the end goal would be, but it's been so fun thinking about just physically affecting space with software that I write. It seems fascinating to me. Have you done any work with any linear actuators or any kind of motors or servos or anything like that?
I have not really.
Oh,
We did use servos in our senior design project, which
okay,
was the greenhouse project.
cool.
We used it as a pinch valve to let water flow or not flow.
Oh, interesting. Instead of like a lot of people that I've seen online use, they actually have like specific valves that are built to do that. But you're
Yeah, I suspect that there are some nicer components than when we did this 10 years ago.
yeah,
Um,
that's a good point.
and of course, we were some dumb college students just trying to make something work. So
It's a
that was the best we could come up with.
half Rube Goldberg machine,
Yeah. Yes.
half electronics project.
Yeah, we had the servo release a marble that fell down a chute that would hit a switch that let the water flow.
Eventually lit the whole thing on fire. Um, did you ever see that video? We had a um, in college. I was in a physics class and we had to make a Rube Goldberg machine, and it literally burst into flames in front of a lecture hall uh, when it completed its task. Um, it was hilarious, but not really that good of a success of a Rube Goldberg machine.
Was
So
was that intentional or not
no,
intentional?
it was unintentional.
That
So
sounds like something a Rube Goldberg machine would do intentionally.
so uh, so the intention was you had to blow out a candle and like do a couple other tasks, and you got bonus points if you started it by lighting a candle. So we of course were working on this the night before it was due, and I had a lot of hemp twine because I was making macrame bracelets at the time and was fascinated by that. And we rigged up the whole thing. We built an awesome Rube Goldberg machine. It was easily the coolest one in the class. Of course, I would say that, but I think it actually was. And the whole thing was tied together, and really everything was held together with this hemp twine. And our big idea as to how to blow out the candle was using soap bubbles, because soap bubbles have some weight to them and they fall, so gravity affects them. And the way that we made our soap bubbles was by using a can of air, using like air duster, like you use for keyboards or computer components. And like it went and did all these cool things, and we went above and beyond, and it was great. What we didn't account for was chemistry, in that the canned air Usually, if you just like do canned air at a flame, it's just going to go out because it's so much hot air pressure. But if you slow it down and have it just be stagnant air and then expose it to flames, it's actually quite flammable. And our soap bubbles reached the candle flame and lit all of the hemp twine on fire. And yeah, just in the lecture hall, all of the whole project was in flames from the soap bubbles. It was hilarious.
Chemistry will get you every time.
Yeah, it's but I think we still got like a B plus or something like that because the teacher was like, "Well, you did the physics part right. You just didn't do the chemistry part right, and that's not what this class is. So we'll still give you a pretty good grade."
That's hilarious.
Yeah, it was quite good. One of my project mates dumped her bottle of water all over it to put it out, and oh, hilarious. That was good. Anyway, see, I'm a little tired, so any kind of scrap of a story will completely distract me as we're trying to get something done. So I apologize for the excess of asides here. So project 3, we're gonna get into it. So cool, and I guess going back to your example about the pinch valve, that is kind of what I'm excited about these basic servos and things like linear actuators, is that you can do so many things with them. You can do so many like physical things. It's kind of up to your creativity to how you can utilize them. So using something like that to pinch a tube for water it's quite brilliant. So and it's just what the fancy valves probably do anyway. So that's quite cool. So before I get too distracted again, let's start working on this, huh? That sound all right? Okay. So circuit 3A, servo motors. In this circuit, you will learn how to wire a servo and control it with code. Servo motors can be told to move a specific position and stay there. Low-cost servo motors were originally used to steer RC airplanes and cars, but they have become popular for any project where precise movement is needed. They have a little bit later in here, they're talking about stepper motors. Are stepper motors and servos similar in their design, or are they put together a little differently?
That's a really great question that I don't know the answer to.
That would make sense because you just told me a little bit ago you haven't used these, so I should have picked up on that. We're going to find out together, Zenhavr.
I can't wait.
It's going to be awesome. So servo motors. Regular DC motors have 2 wires. When you hook the wires up to power, the motor spins around and around. Servo motors, on the other hand, have 3 wires, 1 for power, 1 for ground, and 1 for signal. When you send the right signal through the signal wire, the servo will move to a specific angle and stay there. Common servos rotate to over a range of about 0 degrees to 180 degrees. The signal that is sent is a PWM signal, which, as we learned before, was a pulse width modulation signal. The same used to control the RGB LED in Project 1. Included with your servo motor, you will find a variety of motor mounts that will connect to the shaft of your servo. You may choose to attach any mount you wish for this circuit. It will serve as a visual aid, making it easier to see your servo spin. The mounts will also be used at the end of this project. So I think let's bust it out, huh? Let's take a look at it. Empty bags. This is, looks like a SparkFun breakout board of some kind. This is the motor drive. I've also been looking at a lot of stuff on SparkFun, which is dangerous. They have some really cool, like some things with like the quick connector look pretty cool.
I have definitely spent quite a lot of money at SparkFun in my years.
It is. It's one of those organizations too where you're like, Yeah, I know it's expensive, but it's an open source project. They're doing so many cool things for education in the world that I don't feel bad spending money with them. And it's like, no, you're still spending money. It doesn't change that particular thing. I like them. They seem like a good company. Some other toys that I have played with. Okay, this here is the servo motor. I was looking at, like, they have some cool GPS modules. They have some cool, they have a pH sensor. The pH sensors are expensive. Good lord. Like $200 for a pH sensor. But one thing I thought was really cool is they have some other kits that I've realized I have most of the components for just with this kit. So I might be looking at just doing a few additional purchases in order to expand the number of kits that I have. So, without actually buying the kits, but just buying a few components that are cheaper. I'm going to attach this here. So I've just attached this little flapper. What would you call this, you think? Not a flapper, that's not right.
A doohickey.
A doohickey. The thingamabob.
An arm, probably.
Yeah, that's good.
A motor arm.
You know, I don't actually need to screw this down because it actually is quite firm. But I wonder if it tells me to do that actually. Let's see. A strip of adhesive dual lock fastening tape is included with your kit. Cut 2 pieces of it to temporarily affix your servo to the base plate. Oh, I don't know how I feel about that, but I'll do it anyway.
Yeah, it's probably not necessary.
Yeah,
Just watch it wildly swing around, freestyle.
Yeah, let's do that. I think that's okay. I kind of don't want to tape it down because then it makes it like less of a modular component that I can play with on my own later. Plus, adhesive is sticky. So I think these 2 screws, because there's 2 of them, I'm guessing that they go on either side here. I can hold this up to that. They go through that hole and that hole. So this flattened one, I believe, is what fits in. It looks like this the screw head is the right size. I am going to fix this here just because I don't want it to strip. If I can reach my screwdriver in my pocket. Pick one. Okay. I'll fix this in place. There we go. Okay, now that that's done, sweet, we're gonna play with the servo. I'm psyched. Okay, the next thing we'll talk about here is a new concept, the duty cycle. Pulse width modulation, PWM, is a great way to generate servo control signals. The length of time a PWM signal is on is referred to as the duty cycle. Duty cycle is measured in percentage. Thus, a duty cycle of 50% means the signal is on 50% of the time. The variation in the duty cycle is what tells the servo which position to go to in its rotation. Oh, that's it. Do you have any light to shed on these duty cycles?
They're a pretty straightforward concept. A PWM signal has basically 2 attributes, its frequency and its duty cycle. The frequency dictates how much time elapses before each spike occurs, basically.
Okay, and these would be spikes
Yeah.
here.
Yes. And then the duty cycle basically tells you how long each one of the spikes should occur before it goes back down to, to ground.
Okay.
So if you think something with like a 100% duty cycle is a signal that's on 100% of the time and is indistinguishable from just straight up power being applied to something. 0% is the opposite. It's on for 0% of the time. And then everything in between, um, yeah, everything in between, it covers the whole gamut between that.
So inside of here is probably an integrated circuit, I'm guessing.
Yes, almost certainly.
So there's a little microchip in here, a little integrated circuit that then reads that, and that hard, like baked in, you called it, that baked in circuit knows what to do with the different duty cycles and frequencies. Like that's probably built into that as to what to do.
Yeah, that sounds right. I don't actually know for sure how a servo actually works,
So
so
we're gonna be, I'm gonna be YouTubing the heck out of this. This is gonna be
it
great.
sounds like a fun, interesting topic to look into.
Nice.
One interesting application of like PWM signals and varying the duty cycle is that's basically how a dimmer, a light bulb dimmer works.
Oh, really?
Yeah, so you can, a dimmer that's very close to its its like lowest point is sending power to a light bulb only a very small amount of the time, and an incandescent light bulb basically just takes power and converts it into light in a slow way. So you could, on a higher frequency signal like 60 hertz,
Hmm.
like our AC power systems are, if you kind of chop off 50% of that light bulb only gets turned on 50% of the time.
And
But
it's
since
just,
it takes some time to like respond to it, since it's incandescent, which is really slow, you basically just get a dim light bulb.
oh, so you don't actually have any like any flicker or anything like that, right? Because it's so slow.
Definitely not with an incandescent.
Okay. But that's probably why non-dimmable LEDs give people headaches when you
Yes.
try to dim them.
Yes, that's why you need, specific dimmer switches that work with LEDs and specific LED bulbs that say that they're dimmable,
Hmm.
because it's a completely different story than incandescents with regards to like switching time and stuff like that.
Do they just? I wonder for dimmable LEDs and LED dimmers if they just do it faster or something, or
I really couldn't tell you.
do some other. Hmm. My questions have just end up with more questions. And we probably won't. I'm still going to be ending tonight at 10 o'clock. So we'll get this hooked up. I think that'll be good. It's already 9:45, but we did start a bit late. And I'm so easily distracted today. Um, so we're also going to learn about Arduino libraries. So writing code that sends precise PWM signals to the servo would be time consuming and would require a lot more knowledge about the servo, which of course we're already talking about wanting to know. Luckily, the Arduino IDE has hundreds of built-in and user-submitted containers of code called libraries. One of the built-in libraries, the servo library, allows us to control a servo with just a few lines of code. Exclamation point. To use one of the built-in Arduino libraries, all you have to do is include a link to its header file. Oh, this is cool. A header file is a smaller code file that contains definitions for all the functions used in that library. By adding a link to the header file in your code, you are enabling your code to use all of those library functions. To use the servo library, you would add the following line to the top of your sketch. Include servo.h. What does .h stand for? Header?
Header.
Nice. Are you outside of the hobby Arduino things, are libraries like this fairly common to be used?
Extremely.
Extremely. I bet that's like
This is almost like this is bread and butter of like C++ and a lot of different object-oriented languages. The idea of class files, header files, and segmenting code between them.
sure. Um, I suppose like um, proprietary libraries are the most protected and um, jealously guarded pieces of intellectual property a company might have, right?
That is absolutely true. Yeah.
I can see why. Is it even to a point where I wonder if companies um, would like for some integrated libraries, I could imagine even like not like just telling you how to use the library, not like showing the actual library off ever or
Yeah, it's definitely possible. I think that's essentially what DLLs are in a Windows file system.
oh,
Those are what does DLL stand for? Something library. Dynamic link library is
okay,
essentially a library that's been converted into a format where it can be used by code, but is not easily you cannot easily or even at all look at the source code that went into creating that DLL
just through obfuscation or
through not through obfuscation because obfuscation can be undone.
sure,
Um, it is basically taking what would be output from compiling a source code
sure,
file into like its machine code essentially. That's my understanding of it at least.
interesting.
So like if you have the source code, you can always use a compiler to get the assembled code or the compiled code. But if you have the compiled code, you can't like take the compiled code and the compiler and get the source code from it. It's a one-way conversion.
I
My understanding is that like a library, like a DLL, is the second part of that.
I love how this touches on something that I talk about a lot in my classes, and that's like why is WordPress so much of a security risk for a company? And that's because WordPress is open sourced, so all of the source code is readily available and not so jealously guarded behind DLLs and other types of things. So people can actually see like what makes it tick. Um, and is that it kind of makes me curious about large companies utilizing like open source libraries. Is that a thing that happens? Like, is it like I'm sure they must like have like sets of proprietary libraries as well as the open source ones that are more accessible.
Yes, that definitely happens.
Interesting. Cool.
I can't speak specifically to
Yes.
what we do at our company,
Yep.
but definitely there are like popular open source libraries that get pulled into proprietary ones. And the licensing terms of those open license ones matter a lot as to how they integrate with closed license
Oh,
systems.
that's cool.
So like some open source, some quote unquote open source libraries have open licenses that say that they can't be integrated into a closed source library, or like you have to release all of the source associated with a project that uses the open source library,
Oh,
right? And then there
really?
are other open source libraries that are like, yes, you can use this in your commercial system and you can sell it and you don't have to release the code of your closed system things. You know,
I didn't know
open
that at all.
source isn't just one thing. It's a lot. It can. There are a lot of different licensing terms associated with open licenses.
Do you think that those sort of asterisks create much more is it like a self-replicating open source project that like people choose to use these open source libraries because they're great and then they open source their stuff and have the same type of licensing and then other people use that stuff. Hmm.
Yes, there are definitely open source licenses that are specifically crafted to sort of be, uh,
Like an Agent Smith.
yeah, like I want to use the word parasitic. Like they basically they
Viral,
yeah they
maybe?
yeah the viral licenses. I think that might actually be the term.
Oh, cool.
They contaminate whatever they are attached to and turn them into open source.
That's funny. That's interesting. But I mean, why not? Why not try to, like, if you make something cool and say you can use it for free, why not try and use it to better the industry as well?
Yeah, for sure.
Um, I think all we're going to get to today. Well, this is a pretty simple diagram, but I think I might try and just quickly rush the hookup, and we'll dig into more questions next week. I think on stuff just to try and finish maybe at 10:05 if you're available for that, Zenhavr.
I definitely am.
I don't know if you can tell, but I could ask you questions literally for hours and hours about these things.
Should just have a session where we just sit down and do questions. Although that's kind of what this
That's
was.
what this was, yeah. But maybe we'll do this every couple of them. Leading musician says perhaps Neo and Trinity need to be brought in. That's a good point. Um, Although it's one of those things where Neo and Trinity I think would be all about open sourcing stuff. Maybe Neo is more of that viral open source code. I don't know. I kind of want to watch The Matrix again though, for sure. But thank you, leading musicians, for catching my Agent Smith reference. I appreciate it when people catch. Is Matrix an obscure reference at this point? I think it might be. So I'm gonna start unhooking all this stuff from our previous project, starting from scratch. So pulling out all these jumpers before I pull out the components because it's kind of hard to see the components. Kind of hard to see the components with all these jumpers in place. One thing I've been learning about too lately is about the different like brands or styles. Nice. Leading musician says, "Well worth watching again. I watched the first and second one a few months back. It's excellent. I think they're making another one too." So one thing I learned about these wires is that there's actually certain like styles that people like of these. So I don't actually remember what this style is called, but there's like this one and a couple other ones. Some people recommend, especially if you're a beginner with this stuff, is that actually if you have, I don't have any Cat5 cable handy, like within arm's reach, but the wire that's inside of here is very similar to the individual strands of wire inside of a Cat5 network cable. And so if you were like you are hard up for some additional jumper wires, you could cut apart a Cat5 cable and use those. Which I vaguely remember you doing at some point, Zenhavr, on a project that I saw. Maybe?
Back in our college days, we definitely cut up Cat5 cable and used it for various things.
I think I used some for some art projects at one point.
We found a giant spool of it in the dumpster once, and
Nice.
so we were basically doing whatever we could to find uses for it.
Yep. That's wonderful. Don't dumpster dive, kids. It's not good. We would never do that in college. That was a lie. So many free things in dumpsters in college. It's wild. Okay, so let me put these back. It looks like we're looking at, these are all 330s, I believe. I think these ones here are all 330s. I'm just going to put them in the corresponding one. For my resistors. One topic I'm really excited to learn about as well is transistors. I'm hearing a lot about transistors, but at a conceptual level, I don't have any understanding of them. So I will stop there, but am excited for when we start to play around with them in this kit, because they seem to be a particularly useful thing. Because a MOSFET is a type of transistor, right?
That is correct.
Um,
The last three letters, FET, stand for field effect transistor.
oh. Those are used in a lot of power, like they're halfway to a relay, kinda.
They are, yes.
V. Kruger says, I would figure you'd be hearing more about Hades right now. I don't know what he's referring to. I might have made a comment a while ago and we got lost in the delay. V. Kruger, please explain your joke immediately. I don't understand.
Yes, I will note that
good.
I
That is a
spent
good joke.
probably two or 3 months in a certain class in college learning solely about transistors.
Oh, good.
They are the bedrock of all modern computers, and as such are insanely important to understand at a very deep level if you are doing like electrical engineering.
I'm sure it'll be no problem to summarize in 20 minutes. That's not true.
I mean, at the most basic use of them, right, is they're a digital switch. There's basically an input and an output and a control. And when you think about a switch, right, you think about like a light switch or something, you have to physically turn it on or off in the real world in order to let power flow or not flow. A transistor lets you turn power on or off through that line using voltage, using like an electrical signal.
And but it's a 1 or a 0. It's not like a modulated one.
Yes. Yeah, digital logic.
Okay.
Transistors. The asterisk here is that transistors are so much more than what I've just described, but that's as far
It's a
as we should
huge
probably get.
blinking red asterisk.
Yes.
Thank you for pointing that out, V. Kruger. Episode. I'm just gonna put question mark for now. Episode what? Take my info here. V. Kruger, that was a very good joke. Thank you for explaining it to me. And so, okay, so that does kind of, and a digital signal, either the 0 or the 1, not an analog signal, which would maybe not make sense in that question might not make sense.
It does make sense. It would work the same way as a digital input or output on the Arduino, 0 or 5 volts.
Okay. Yeah, you're welcome, V. Kruger. Okay, so that's interesting. I am excited to play around with them. Got H dunk on telephone. See if it's stream related. No. So finish pulling these off. The Nipix pliers, everyone. Everyone needs to have at least one pair on their person all day, every single day. I don't quite sleep with mine under my pillow, but I'm thinking about it. I just love that earlier today I was using this to loosen a nut that was like 1 1/4 in an 1 1/4 hex bolt, using that for that, and then I can just delicately pull out electronics from the board. Okay, all of that's put away. I definitely like the idea of I also, one of the things I was looking up online, Zenhavr, was a 3-ring binder trading card holding sleeves. Thinking about all of these little bits. Do you feel like that is a good way to keep things organized still?
I definitely have a 3-ring binder with those card holders holding my resistor kit right now.
Do you do that for all of your components or just the resistors?
Just I only have them for my resistors because a lot of other components like integrated circuits are too thick to make that nice and flat.
Okay.
So things like resistors and capacitors go really well in a holder like that.
I also have like one of those like little drawer pulls that you might use for like screws and other
Yes.
hardware like that. Is that a good storage for some of these things?
Absolutely. Yes.
Okay. Cool. But that's also dangerous because if I have enough things where I need to have an organization strategy, that means that I might have too many things. But
It's a slippery slope for sure.
It is. So, okay, so what do we need for this project? We need our potentiometer that we just put away. I'm smirking at B. Kruger's response to my burn. Okay, and we need wires in the servo. Sick. Cool. That's all we need here. So I'm going to place the potentiometer where it tells me to in B1, 2, and 3. Now, this is saying to put it in B1, 2, and 3, but I can never understand why it's asking me to put it there because there's actually not like that much extra room. Why wouldn't it just tell me to put it in A1, 2, and 3? I don't understand. I also, my camera is out of focus. Give me one moment.
Yeah, it's not clear to me either why that would be the case.
Okay. One potential idea for one potential idea I have for a project with this servo is to actually just hit a button and have it lightly touch my camera's shutter button so that it refocuses for me, because otherwise I have to stand up and touch it in order to get to refocus. That could be an awesome little project. And I was also thinking about a focus controller, building a focus controller with a servo motor to adjust the focus ring on my camera from my desk here. It could be quite useful, actually. So let's see here. This in place. This goes up here. It's right there. Then our servo just kind of exists. It doesn't go on the breadboard. It has this kind of connector on it. This sort of thing. Do you use these kinds of connectors that much, or have you used a lot of these in the past?
Oh yeah, here and there.
Because this basically fits right into like a pin out, right? So like pins that look like this here is what this kind of connector is intended to plug into. And actually, isn't it just like the upside down version of these?
Yeah. Yep.
Okay.
That's like a pretty common, probably like 0.1 inch width connectors or something like. It's a very standardized thing.
Cool. And it's in inches, not metric?
I want to say it's 0.1 inches, but I can't say for sure.
That's wild. A science thing. I hear you looking it up.
I am.
A sines thing that's not in the metric system. That's bizarre. So we're plugging the potentiometer into the first of the analog inputs.
I can confirm that it is 0.1 inches or 2.54 millimeters.
What? Clearly an American invention. Maybe.
Uh, yeah, sure. Who knows?
Imperial system is just terrible. I hate it. Are things at your place of work typically done in metric for any measurements?
Honestly, I don't know. I don't actually look too much at our schematics for the electronics to know that.
Hmm. Whoa, whoa, whoa. Wait a minute here. Looking at this illustration, it's having us hook up the ground on the board, not to the ground at the top of the breadboard. That seems strange to me. Like, why would you connect it here? Sorry, here. Why would you connect it here instead of at the top of the breadboard where it usually goes? So this one at the top of the breadboard goes to the servo. That seems strange, doesn't it?
Well, that entire rail is connected all the way through, so you can plug your source of 5 volts and the source of ground anywhere along that rail, and it will work just fine. I can't say for sure, why they chose to do it this way. Maybe because the the control signal. No, I couldn't tell you for sure.
I think I'm gonna do it different because it seems so disorganized, doesn't it?
I think you can absolutely feel free to do it differently.
Um, I think one of the things I really like about doing this kind of work is that my tendency to be obsessive about details is an asset in um, this sort of activity. It seems like so good on that. I guess it doesn't actually matter, but being detailed oriented is sometimes not good, but it looks like it might be okay here, right? Let's see.
One reason one could choose to go for the middle of the rail connection is that minimizing wire length is nice for like aesthetic
Oh,
purposes.
okay,
But here, you're using jumpers that are the same length no matter where you plug them in. So,
right.
but if I were cutting a wire specifically to like plug power and ground into those rails, I would likely put them straight across.
That okay, that makes sense. That's why I love these Y things because then I can kind of grasp some of it. Um, and this is different than some. I don't know if it's different from breadboards that I've seen, but I've seen some breadboards where, I mean, I think I'm remembering it correctly, where they have like the positive and negative, like, or they have like single cells at the top that you can choose to plug the positive and negative into for the whole rail.
I could see that being pretty nice if you were to fill like that entire breadboard up with integrated circuits and each one of them needed to like connect to a rail. It would
Mm-hmm.
be annoying to have to use one of the rail slots to source the power and ground. So I could see it being nice having a dedicated rail input for power and ground.
Um, we're gonna pretend that's what our situation is. That's a good point about the length of wires, though. And in my other kit, the Electronics Learning Lab definitely has varying lengths of wire. That's going there. That's going there, and then this. I'm actually gonna put it at the bottom. Down there. seems logical to put it there. Blue wire is hooked up to analog input, or it's to analog, whether it's input or output is up to me. Oh, that is actually in, analog in. So this does not have an analog out.
That is correct.
That's
There
probably,
is actually very few uses for an analog out sort of functionality. I shouldn't say very few uses. It's really hard to make an analog out
everything
in
else is done with
a microcontroller.
everything else is done with pulse width modulation, right?
Uh, Not necessarily. It's like physically difficult for a microcontroller to sort of drive an analog an analog output, if
Okay.
that makes sense.
Yeah.
Like the electronics are difficult for such a small integrated circuit to do. I don't know if that makes sense or not, but
Yeah.
there's good reasons for why like a microcontroller doesn't have an analog output pin in some
It's
cases.
it's hard and it would make it more expensive.
That's one of the reasons, yeah.
These all hooked up. Groovy. Okay. So here's our whole setup here. I'm gonna zoom out a little bit. We have here's our servo here, connected through this pinout connector here. We have the white wire going to digital pin number 9, which has a tilde on it, which means that it has pulse width modulation available. The blue wire is hooked up to the, actually, I think we're missing a wire on our potentiometer here. We don't have the 5 volts to our potentiometer. So the wire reading, so the blue wire here is the one in between the ground and the 5 volts for the potentiometer, which is going to read the difference of the two, right? Because the potentiometer is a variable resistor, and the variance is read out through the blue wire here, or the center pin, into the analog in. Did I get all that correct?
That is mostly correct, yes.
Okay. Where is there a specific spot that I
So you are reading a voltage on the blue line.
voltage? Okay. Yep.
So the potentiometer, since you're supplying power and ground on either side of the wiper,
Yep.
the middle output, the blue wire output, is basically taking the voltage divider result
Between the
between between the resistor, between the wiper in the resistor.
Is it a single resistor in a potentiometer, or is it two?
It is physically a single resistor, but you should think about it as being two resistors.
Because you know what this sounds a lot like is some of what we utilize, some of that push, or that pull up and pull down.
It certainly harkens to that discussion, yes.
Okay, using two resistors and the difference between the two in order to send some kind of signal.
Yes.
Neat. Okay.
So
Okay. Cool.
the 2-second explanation of what you have set up here is that based on where the position of the potentiometer is, the blue wire will range in values from 0 to 5 volts.
Yeah. And then the resolution of the board, I think the resolution of the board is going to split that into between 0 and 1023 on the serial connection, right?
That is 100% correct.
Cool. Okay, cool. See, I'm remembering this stuff. I'm excited. All right.
Very good.
Very good. Getting it. Getting it. Okay. I'm going back to ye ol' Arduino IDE. I'm going to open up Circuit 3A. I'm going to close these other circuits because why have them open? Okay. Then I'm going to plug in this deal. Now, as I did that, I heard a little zzzt from the servo. I think I should have probably uploaded a nothing file between these two things, between these two projects.
That is probably not necessary.
Okay.
If you think about the signal that's being sent to the servo, right? Like it's a PWM signal,
Mm-hmm.
and the PWM is between 0 and 100%. It's
Mm-hmm.
likely that the default state of whatever value is being sent to the servo is just, a flat line
Sure.
ground, which is a
Yeah.
PWM signal with 0% duty cycle.
Yep. Okay.
So it's likely seeing that, having power applied to it, seeing no signal coming in on the signal line, and basically just going to that position.
And then I think what this is probably doing is it's tying the potentiometer signal to the servo position. And
That would be my guess.
potentiometer is 180 degrees as well. So let's look at this at the software here. So include servo.h. Oh, I'm gonna have a lot of fun digging into libraries that are attached to this. Now, when you have these,
I bet there's a lot of documentation on the Arduino reference manual online.
that's right. We started looking. Oop, let's not do that. Um, that's like what I just did is like a worst nightmare for whenever I've trained in content managers for work that I've done or anybody doing coding. I'm just like the first skill you should learn about doing anything with any code is just to click very intentionally and get good at using your mouse, because that would break everything. So all I did was just select this and accidentally click and drag the highlighted portion. Yeah, I'm gonna have to dig more into that Arduino documentation, and that kind of documentation would probably be what is something that you'd get included if you purchased, let's say, a specific sensor or device module.
It is very likely that any common piece of electronics, like anything that you'd find on SparkFun,
Mm-hmm.
likely has some open source library that someone has written and provided for free. So
Cool.
even if there's not something from the manufacturer, I am almost certain you could find something open source online to just pull into your project and use.
And when you say something, you probably mean like 100 somethings.
Yes. 100 somethings that have been very cutthroat, picked apart by other people in order to perfect them, with the one true library emerging to the top.
Excellent. Okay, so servo, my servo. Interesting. So it's
Now, general question here. How
yeah.
much experience do you have with object-oriented programming, like what we're seeing here?
Um,
I'm just curious. I don't know
yeah.
what your background is on object-oriented programming languages.
Anything that I've done in object-oriented programming has been learned through observation and just kind of getting my hands into some software that I was playing around in. Um, Specifically in a kind of Java environment. This goes to the browser scripting I was doing as a part of Selenium IDE. So I was doing
Okay.
some Selenium work through what's called this tool called Contu, I think it's called, to do some scripting around like data scraping on websites that I've used for work. So we had like a number of things that we needed to audit in a system that the backend was closed to us because Salesforce are jerks when it comes to certain types of data. And so we needed to pull them from our dashboards. And I have a piece of software that I wrote, a script that I wrote to go through and pull that information out. In there, I'm using a couple different objects and a couple different functions and things, but no real solid training on it. Fumbling in the dark is the answer.
Ah, gotcha. Okay, good to know. This is some pretty simple object-oriented programming, so I don't think you will run into any issues. But it may be it may be a topic for deeper diving at some point in the future.
Cool. So this is calling the library. This is saying library, and then like within this library create this function? No.
This particular line of code is declaring a servo object
Okay.
and calling it myServo. So now myServo is a variable just like pot position and servo position that you can work with in the code.
But these two things are not related whatsoever.
They are related because servo.h provides the definition of what a servo object is.
Okay, sure.
So if you didn't have that include servo.h and just had a line of code there that said servo myServo, when
Mm-hmm.
you went to compile this code, the compiler would basically say, I don't have any idea what a servo is.
Yeah.
What are you trying to do here? This is an error. But as soon as you provide the definition of what a servo object looks like by including servo.h, then it's like, oh, okay, yeah, thumbs up. That's a servo.
Sweet. Okay. That makes sense. This is declaring an object, and this kind of looks like how we declare a function. Like this is a function because of the parentheses, but this is just a variable we're creating, right?
That is just a variable, yes.
Okay. This is a function on top of the variable. So this is saying for this object, do this function. That kind of right?
Yes. Yep. So a servo object, or really any object,
Mm-hmm.
will can have functions associated with it that are defined as a part of that object's definition.
Okay.
A servo object, according to this, has an attach function that you call using the specific servo object that you've created.
Which would be buried in here, probably, unless it's maybe mentioned down here. But I don't see.
Yes. The definition for what the attach function, what the header for the attach function is
Yeah,
defined in servo.h.
because we're not seeing attach declared as a function in here at all,
Correct.
which tells us this is in the thing we referenced up here. Cool. So attach tells the servo object that its servo is plugged into pin 9. Okay, so this parentheses right here, 9, is referring to the pin number 9. Okay. Pot position analog read, analog 1, or the first analog pin. Servo position map. So map is another function that's referred to in this servo.h. So it'd be, if you're going to
Um,
use, oh, maybe,
I
go ahead.
don't I don't actually think so. I think
Oh,
map is a common Arduino function. If you were to
oh,
like go look at the Arduino reference guide, I believe
sure.
map is a general purpose function
Okay.
that basically takes two ranges of values, in this case 0 to 123,
Mm-hmm.
and converts it to 20 between 20 and 160, I believe.
Okay. And the comment here says convert the potentiometer number to a servo position from 20 to 160. Okay.
So if you think the map function is basically mapping a value that is between 0 and 123 to
Mm-hmm.
another value that's between 20 and 160.
Okay.
So if pot position in this case was 0, the value you'd get out of this would be 20
Mm-hmm.
because you've mapped 0 to 20.
So if we wanted our servo to only move a little bit, we could just shrink these numbers, or have this number larger and this number smaller.
Yep, if you made it like 80 and 100, for
Yeah.
example, your servo would barely wiggle.
And give you finer control.
Yeah, yep.
Okay, note, it's best to avoid driving the little SIK servos all the way to 0, 180 degrees, as you can cause the motor to jitter, which is bad for the servo. Good to know. Thanks, comment. My servo dot right servo position. Okay, so this is saying, okay, hot position is this, servo position equals hot position. Okay, that makes sense. So, going back to this little fun thing, I'm going to wiggle this potentiometer and it's going to move the servo. Neat. This feels like magic. This is weird. I like it. So I'm just twisting this little potentiometer, and it's very, very directly controlling that servo. That's cool.
We did it.
We did it. Neat. It is 10:25. There's
Overshot a little, but
overshot a
that's
little
okay.
bit. There was so much was learned today. So many questions. I'm actually going to this week when I have a question, I'm going to write it down in a long list, and maybe I'll send it to you shortly ahead of time, or I'll try and surprise you with more questions that are deeper and deeper down rabbit holes. We'll see.
Excellent.
Um,
The quiz
this
is tomorrow, so
Yep. Um, I so appreciate you talking me through these things. I feel like I'm just so fascinated by this stuff, and it really has been a topic that I've just wanted to know for so long. I've wanted to dive into it. So I'm just pleased as punch to learn about it now, and I feel like I'm not just getting definitely not just getting the SparkFun version, which would only give me more questions. I'm actually getting some answers to things, and I feel like once we're through this, I'm going to have a pretty solid understanding. And I'll need to make sure to stop myself from really probably visiting the SparkFun website at all until I'm done with this kit. Because, gosh darn it, it's going to be tempting.
yes, well, I'm very happy to do my best to teach someone about this kind of stuff. So
Cool.
very happy to be here.
I love it. So excited to invent stuff too. I really want to do some, and even if it's inventions that other people have invented 1,000 times, it's kind of fun to like come up with solutions to things. So I'm excited about that as well. Once I'm done with this, I didn't bring it down here, but I have a Raspberry Pi project that I've previously gone to SparkFun and bought a bunch of crap and bought some other like circuit boards and stuff, and I didn't really understand what I was doing or have enough of a grasp to actually hook things up. So once we're done with all these projects, I think I'm going to be working on that. That's the and I may have linked you to it in the past. That's the Pelican case Raspberry Pi CyberDeck project.
Yes, yeah, that one is a very interesting one.
I'm really excited about this keyboard. Actually, was initially purchased for that project. So this keyboard fits in with a very small additional amount of room perfectly in the Pelican case for that project. So I'm excited about that. But one of the main things that I want to do with that is I have a buck converter for I'm hoping to hook up 12-volt power to run my Raspberry Pi. A 12-volt power into the buck converter and have it be a step down, I think is the right term, a step down buck converter to bring it down to the necessary 5 volts. Before I do that project, I might pick up a much cheaper version of the Raspberry Pi in case I fry it in my attempts to do this project. So we'll see how that goes. But I'm excited about that at some point. Thank you so much, everyone who tuned in and watched me learn some of this stuff. Thank you so much. We're going to be doing this every Sunday at 8 o'clock until my brain is full on these things, and probably from there just going into more electronics projects, after a few months of this, I think. Thank you, Zenhavr, for joining us tonight. And I'll be streaming The Long Dark on Tuesdays at 5. Tuesday at 5, The Long Dark. Going to be playing a few hours of that, some relaxing, stumbling through a frozen wasteland in a video game. And on Thursdays is when I do more crafty things. I still have a couple knives to sharpen. I've been doing a sharpening stream for a while, and that's going to be Thursday at 7. I think I do that at 1 at 7. So tune in, and it'll be fun to see you there. And yeah, have a good night. I have an axe to grind. Hey, that's good. Maybe I'll sharpen some axes. I have a few hatchets that need some sharpening. I don't have a jig for it though. I should really figure one out. I know. Good stream title idea, V. Kruger.